Hello students, my name is Shivali and today I am going to teach you one of the important topic of 11th class, that is cube root of unity, which is from the chapter complex number. So what is the cube root of unity? We all know in complex number the number z, the alphabet z denotes a plus I b, where a is the real part of z and b is the imaginary part of z. Now I am saying the cube root of unity. Let's say z is equal to 1 and it is cube root of unity like this one, or we can write it as this. Okay, z is equal to 1 raised to power 1 by 3. Now we will cube it on both sides. When we will cube it on both the sides, we get z cube is equal to 1, or we can write it as z cube minus 1 is equal to 0. Do you know this formula? This is a cube minus b cube formula, which can write it as a minus b, a square plus ab plus b square. This is the basic formula. You can use. I hope you studied it in algebra. Okay. So apply this formula in the equation. We can write z minus 1, z square plus z into 1 again z plus 1 is equal to 0. Either z minus 1 is equal to 0 or z square plus z plus 1 is equal to 0. From here we get z is equal to 1, or from here we cannot find or we cannot solve this quadratic equation because somewhere we get some negative square root value. Firstly, we will try to solve it in a simpler way. Let's say minus b plus minus under root of b square minus 4ac upon 2a. This is Sridharacharya method to solve the quadratic equation, where b is equal to this is 1 plus minus under root of, again b is 1 minus 4 into 1 and 1 upon 2a. I hope you can see it. Otherwise, I will write it again here. Minus 1 plus minus under root of 1 minus 4 upon 2, which is minus 1 plus minus under root of minus 3 upon 2. See, we already studied about it that under root of minus 1 is I, which is used in complex number with imaginary part of z. So we can write it minus 1 plus minus I under root 3 by 2, or minus 1 plus I under root 3 by 2 and minus 1 minus I under root 3 by 2. So in totality we have three values of z. That is 1, minus 1 plus I under root 3 by 2 and minus 1 minus under root minus I under root 3 by 2. This is 1. We can represent it by omega and this by omega square. Okay. So we have three values in cube root of unity. In case of complex number, we always have this three value 1, omega and omega square, where omega represent minus 1 plus I under root 3 by 2 and omega square represent minus 1 minus iota under root 3 by 2. Okay. So after this cube root of unity, after this concept, I will discuss some questions with you. Hope you understood this concept. So we will discuss our first question. See, we have two values given here, that is minus 1 plus under root of minus 3 by 2. Okay, and minus 1 minus under root of minus 3 by 2. You know what is this value? This is minus 1 plus under root of minus 3 by 2 can be written as minus 1 plus I under 3 by 2, which is, you all know, omega. And this one, minus 1 minus I, we can write it as minus I under 3 by 2, which is omega square. Okay, now I put this value directly in the question. The value is omega raised to power 17 plus omega square raised to power 17. See, we have two important formula of this omega. The first one is omega cube is always equal to 1, and the second one, 1 plus omega square is always equal to 0. This is the important one. Okay, you have to remember these two formula. So now we will solve it as, see, omega raised to power 17 and omega square, multiply the square with this, 7 to 14, 34. Now split it with multiple of 3. 3, 6, 18. 3, 6, 18. So 3, 5, 15 and omega square. Because 3, 5, 15 plus 2 is equal to 17. Plus again we can split it in the multiple of 3. So 3, 1, 3 and again 3 into 11 is 33 and 1 is here omega. So the multiple of omega cube is equal to, not multiple, omega cube is equal to 1. That raised to power 5 is again 1. Omega square plus this again 1 raised to power 11 into omega. We get omega square plus omega. Do you know what is omega square plus omega? From this equation we get omega plus omega square is equal to minus 1. So we get the value of this equation is equal to minus 1. This is our question first. Solution of first question, that is minus 1. This is the interesting topic of 11. You have many interesting topics, but the cube root of unity is the interesting part and the scoring part of complex number. So we will get to the next question. The question number 2 is, hope you noted. Question number 2 is omega cube. It is a direct question, you know. Omega cube upon I raised to power 13. In the very start, we read it, yeah, we studied it, that I raised to power 4 is 1. We know. So I raised to power 13, we can split it as I raised to power 4 into 3. 4, 3, 12 and I. This is equal to I. Okay. So we can write omega cube raised to power 13 upon I raised to power 13. We know I raised to power 13 is equal to I. And omega cube is equal to 1. 1 raised to power 13 and this is I. 1 upon I. To make it simpler, we will rationalize it with I. We get I upon I square is equal to minus 1. This is equal to minus I will be the solution of our second question. Okay, this is very simple and important question also. Our last question is, if 1 omega and omega square be the cube root of unity and n is a positive integers, then the equation is given 1 plus omega raised to power n plus omega raised to power 2n. You have to prove it that this equation is equal to 3 when n is a multiple of 3 and this equation is equal to 0 when n is not the multiple of 3. Okay. So we will solve it. all know this is the cube root of unity, and n is a positive integer. First we will take the equation 1 plus omega raised to power n plus omega raised to power 2n. We have to prove it for when n is a multiple of 3 and when n is not the multiple of 3. First we will take that n is the multiple of 3. N is the multiple of 3. Let's take it is equal to 3. Let's take n is equal to 3. Okay. We will get 1 plus omega cube plus omega raised to power 6. So 1 plus omega cube plus omega cube square. We can write it as this. So 1 plus, we know omega cube is 1. Again omega cube is 1. And 1 square is 1. This is equal to 3. We get the answer 3. Or multiple of 3. So we can take it as 6. 6 is also 1 plus omega raised to power 6. Again omega raised to power 6 to 12. 1 plus omega 3. You can split 6 into 3 into 2 plus omega raised to power 3 into 4. Again 1 plus omega cube is 1. Again 1. This is equal to 3. It means it is proved for all multiple of 3. Okay. The second one, if n is not the multiple of 3, let's take n is equal to 2. N is equal to 2. Okay. The question is omega raised to power n and omega raised to power 2n. If n is equal to 2, 1 plus omega raised to power 2 plus omega raised to power 2 into 2, 4. 1 plus omega square, omega cube into omega. Okay. 1 plus omega square plus omega. We know this is the proof equation that 1 plus omega square is equal to 0. Okay. So, this is our class. Hope you like the class. Thank you so much.